In this video, we are going to talk about the definition of polynomials and then how to write them in standard form, classify by degree, and then we'll add and subtract them. So a polynomial can have constants, variables, and exponents, but it'll never be divided by a variable. It usually will look something like this. There'll be different terms that are separated by plus or minus signs. And they, like I said, constants, that's the number that does not have a variable. There'll be variables in it. There can be more than one variable. That's fine. There can be exponents on the variables. That's fine too. But something like 2 divided by x, it will never have x to the, like a negative exponent, because that's the same as dividing by. These terms are separated by plus or minus signs, so these are examples of polynomials and these are not polynomials. I put a link here to some more examples that are and are not polynomials, and they're similar to the ones that are on your worksheet, so you might want to check there before you decide yes or no on these. They also will not have square roots. The variable will not be within a square root. I wonder if I can click on this. So if you have an exponent that is a fraction, like x to the 1/2, that's the same as the square root of x. You probably remember from earlier. And that it would not be a polynomial. So if it has a square root, it would not be a polynomial. So this one would be no. You just have to say yes or no for 1 through 6. So looking at these and looking at that website if you need to, there are 2 of them that are polynomials, so you can go through and check and see if you can figure out which ones follow the rules for polynomials, and there'll be quite a few no's on that section. So that's just kind of a quick check to see if you understand what polynomials are. Then on the rest of this worksheet, we will be next looking at how to find the degree of a polynomial and how to write them in standard form. So standard form is when you take the term that has the highest power and you write that first. So in this example down here, we have squared to the 4th power, that's just to the 1 power, and to the 5th power. This is the one that has the highest term. So that gets written first. The sign in front of that term will go with it. So that's a positive, so this would be a positive as well. And then you go through, and the next one is plus x to the 4th, so they wrote that one down. And then this is also positive, so plus 3x squared. Remember, you always have to separate their terms with a plus or minus sign. And then this one is next, and that's minus 2x, so you keep the minus there, and then minus 7 gets written at the end. To find out the degree of this, you just look at the first one once you wrote it in standard form. This one has a degree of 5 because the first term has a degree of 5. So this polynomial would have a degree of 5. The 6 is the leading coefficient because that is the number in front of the first term. Some of these will get special names, like we already learned about. We know that a linear one, there's no exponent on the variable. We know that quadratic will have the exponent of 2 on the leading term variable. So x squared plus 3x minus 1 is an example of a quadratic. Then there's cubic, which is x to the 3rd. Quartic is when you have x to the 4th. Quintic or quintic is x to the 5th. And of course, these could be different variables than x. It could be y to the 5th. And then after that, we would just call it a polynomial. So there's just special ones for these first 6, I guess. This one is a constant term. It has no variable, just a number. So what you're going to do on 7, 8, 9, and 10 is several things. You're going to rewrite it in standard form, find the leading coefficient, the degree, and the number of terms of each polynomial. The number of terms is separated by plus or minus signs. The degree is given by the term with the greatest degree, the greatest power. And then also we're going to classify as constant, linear, quadratic, cubic, etc. So let's do number 10 together. In number 10, we have negative 3x squared plus 1x to the 4th. They don't put a 1 there, but we could. Minus, that would be minus 1x, minus 2x to the 3rd, plus 8. We have to find the one, to write in standard form, we need the one that has the highest power. So not 8, not x to the third. There's x to the fourth, x squared. X to the fourth has the highest power. I'm going to go ahead and put a 1 in front of it to make later the next question easier. So so far we have 1 x to the fourth. That's a little messy, so I'm going to erase it. Start again. So we have 1 x to the fourth. So I used this one up. That was a positive, so I leave it as a positive. Then the next one is right here, minus 2x to the third. Make sure you keep the term with it. And then is there an x squared? Yes, right here, minus 3x squared. Is there an x? Yep, right here, minus x. Lots of minuses in this one. And then at the very end, the constant is plus 8. That's now in standard form. The leading coefficient is the number in front of the first term once you write it in standard form. So that's why I put that 1 there. So I wouldn't think that there was no leading coefficient. There is, it's just 1. The degree is the exponent on the first term once you write it in standard form, so it has a degree of 4. The number of terms is 1, 2, 3, 4, 5. And to classify this, I look at the degree. So let's go back up to that chart. The degree of mine is 4, right here. If the degree is 4, we would call this a quartic polynomial. Q-U-A-R-T-I-C. Now it's done. Oops, my C moved. Okay, now we're going to do the next part of the worksheet, which is adding and subtracting polynomials. First we'll do some adding, then we'll do some subtracting. So there's more than one way to do this. You could line them up on top of each other, which is the vertical method, which they do here. I'm going to scroll down and then I'll come back. You can also add or subtract horizontally, which is just to write them like this and then to simplify and continue from there. Either method is fine, whichever you prefer. Let's look at 15. So you can only combine if you have the exact same variable with the same power. You can only combine like terms. So in 15 we have an a squared term, and you have to see if there's any more that have a squared. There is no more that have a squared. So that term is just going to get written down by itself. Next one we have a b squared. So look and see if there's any more b squareds. There is. There's a b squared. Here's a b squared. Now, it's very helpful when you're first starting to do this to write them next to each other and then to worry about simplifying in the next step. So there I've got the a squared and the b squareds done. So let me just kind of cross those off. And note again that the sign in front of it goes with it. Now I have a plus 2ab, but I don't see any more of those. Okay. I see here I have a 3.1a, but there's no more a's. There's not going to be much to actually add in this one, and then at the end there's going to be a plus b. There's no like terms except for right here. So those are the only ones that you'll combine. And when you combine like terms, you only combine the numbers that are in front of the like terms. You don't actually combine the variables at all. You're just going to write the variables down after you figure out the number part. So the 6.9a squared, nothing happens to that, but I do have to figure out what is negative 2.3b squared minus 2.5b squared. They're both negative, so I add and take the sign of both. So this would be negative 4.8b squared. And the rest of it is just going to get written down because none of these were like terms, so there's nothing you can do with them. And this is your final answer. It's only a little bit simpler than the original problem, but that's what the answer is. Now, subtracting, you have to be a little more careful. The rule for subtracting is to add the opposite. So the best thing to do, especially again as you're starting these, is to change your subtraction problem to an addition problem and then change the sign of every term in the second parentheses, the second group. So in this one, we changed our minus to a plus, then I changed the 3x squared to a minus 3x squared, the 2x to a minus 2x, the minus 5 to a plus 5. And then you add like we just did in the other one. So in number 17, I wrote those steps out and I started the process. I changed this to minus to an adding, and then I changed every one of these signs. And then I actually went through and wrote the like terms next to each other as well. So now all you need to do is figure out, if I take 5t squared minus 5t squared, what do I get? And then minus 1t minus 2t, and then at the end there's a plus 9. So you can finish that one up. Let's look at number 20 together. So the first step, I'm going to give myself a little more room here. The first step is to rewrite this problem, but adding the opposite of the second group. So I just copied and pasted it. I didn't change anything yet. I'm going to change this to a plus, and then I'm going to take my parentheses away, and I'm going to change this to a negative. I'm going to change this one to a minus. I have to change every sign, and I'm going to change this sign to a plus. Now, and I don't need this parentheses anymore either. Now I'm going to look for like terms. Okay, my first one is 2a squared b. Let's highlight that. Do we find any more a squared b? ab squared, a squared b squared, a squared b squared, a squared b. Here's another one right here. I'm going to highlight that the same color, and I also made sure to include the sign in front of it. Let's just go through and highlight some more like terms here. I have minus 3ab squared. Do I see any more ab squared? So that's a squared, b squared, a squared, b squared, and b squared. No more of those, okay? Next I have plus 5a squared, b squared. And then right after it, I have minus 2a squared, b squared. Those both have a squared, b squared, so those are like terms. There we go. And then at the very end, I have one that doesn't go with anything else, plus 5b squared. So highlighting or underlining like terms is another way of finding them without rewriting them right next to each other. Now I'm going to combine my, get my pencil back. Combine the like terms. So I can combine the yellow ones. I have 2a squared b minus 4a squared b. That would be minus 2a squared b. And then I'll just rewrite the one that's highlighted in green because it didn't have anything that went with it. And now I'll combine the blues, plus 5a squared b squared minus 2a squared b squared. So we just combine the coefficients in front and rewrite the variables exactly as they were. And then at the end, I'll put my plus 5b squared. And that's it. You can just go through, make sure you didn't miss anything, and that's your final answer. Sometimes you can write them in standard form, which is good practice, but something where there's more than one variable, there's no real standard form. So just do the best you can. Don't forget number 21 here. The last section, there are examples on how to do these in your textbook, so you can check that out and try these out. It's a bonus section, so you can skip it if you want or give it a try. It's not too tricky, but... All right, thanks very much and have a great day.